Hi everyone. We will explain chapter 4. This chapter is about alkanes, their nomenclature, cycloalkanes. We'll also explore their nomenclature. We will talk about their rotation, which is conformation of both the alkanes and the cycloalkanes. Any additional reading material you can refer to chapter 3 in the organic book. Alkanes have a molecular formula of CnH2n+2. N is the number of carbons. So this is the molecular formula of alkanes. Normally alkanes, they are saturated hydrocarbons. They are made up of carbons that are connected to each other. This is a longer chain of carbon in there. And they are made up of carbon-hydrogen sigma bonds. Remember what we said, that every single carbon of these is an sp3 hybridization. So if it's an sp3 hybridization, when you place two carbons next to each other, they have to be placed the farthest away possible from each other as they can, so that they maintain low energy structure. So this is why you can see that when we draw an alkane chain, we draw it in a form of a zigzag, just to make sure that every two bonds are in plane. Normally the bonds in the carbon chain, they are in plane. So the in plane bonds that I'm talking about are here. This is the in plane. These two carbon bonds are in plane. So all of these are going to be in plane. And then if you have two bonds in plane, one of them needs to be in front. And as you can see from this molecular model, the one that is pointing towards you, this is the one that is in front. So this carbon-hydrogen bond is in front, and the one that is farthest away from you, this is going to be behind. This is going to be for every single carbon. So every carbon should have two bonds in plane, one in front, and the other one needs to be behind. With respect to cycloalkanes, they do have, their molecular formula is CnH2n. This is their molecular formula in there. Their degree of unsaturation is 1 because they do have a cycle. They have a cycle. Now, with respect to the alkanes up here, they are saturated hydrocarbons. This means that they don't have any double bonds in there. For the cycloalkanes, no, their degree of unsaturation is 1 because they have a cycle. Let me go back a little bit here. We will, as we go ahead and dig deeper in this chapter, we will talk about their conformation and how you change cycloalkanes into their most stable conformation or representation of a cyclic structure. So as we mentioned, all carbons, they do have, all alkanes, they have an sp3 hybridized carbon, and their geometry is tetrahedral. This means that the bond angle between the carbon, the CH in plane, it's going to be 109.5. So the bond angle is at 109.5. Normally the length of the sigma bond between the carbon and the hydrogen is smaller. It's 109 picometer. It's basically shorter than the carbon-carbon sigma bond. When we represent any carbon chain, please make sure that every carbon should have two bonds in plane, one in front and the other one is behind. It really doesn't matter because there is a rotation around the carbon single bond carbon. This is a representation of a 3-carbon alkane. The 3-carbon alkane is called propane. We will talk about nomenclature as we proceed in this chapter. This is the molecular model. You guys, if you got your molecular model set, try to build a molecular model structure of propane, and you can see that you can free rotate around any of the carbon single bond carbon. You can do a free rotation, and doing a free rotation basically will change the positions of the hydrogens here. So if one of them is in front, If you do a rotation, then it will be at the back. It doesn't matter how you draw a chain of carbons. Here I'm showing you that a chain of 5 carbons, this is called pent. Pent means 5. And the ending is A and E, this is for the alkane. So pentane is a chain of 5 carbons. It doesn't matter if you draw it straight, if you basically represent it in any of those forms, it doesn't matter, because all of these forms, they are the same. They represent the same molecule, which is pentane. These are not isomers of each other. The reason why, because see, when you start from the end of one carbon or the end of the chain, you can go all the way, and this is going to be your longest chain. This is the 5 carbons. Here you go. Start at one end and go all the way to the end of the chain. This is another 5 carbon. I can start from here, I can start from there, it doesn't matter, and count the longest chain, and this is basically 5 carbons. So I do have 5 carbons in a row, no branches, so this means that all of these structures are the same. We've talked about constitutional isomers, and we said that constitutional isomers are isomers that have the same molecular formula. So their molecular formula is the same. Here in this case, the molecular formula is going to be C4. H, count the hydrogens. It's going to be 3, 4, 5, 6, 7, 8, 9, 10. So C4H10 for both. C4H10 for both. But I have different ways of writing it. So when the connectivity of the atoms is different, then this is called structural or constitutional isomers. They have the same molecular formula. When you write the constitutional isomers, just make sure to start with your end chain first, and then take 1 carbon and branch it off the chain. Now, with respect to the nomenclatures of the alkanes. Alkanes are named in 2 ways. The most common way we use it is the IUPAC name. This is the method that we use in order to name alkanes. There's another way that we normally name alkanes, and that way is a shorter way that we use, which called common names. I'll show you both, and I'll show you how to incorporate common names with IUPAC names, because in most of the time we use both together at the same time. In order to name alkanes, this is how this is the actual name over here. Just let's break it down. The actual name of an alkane compound is made up of a parent name. A parent name is the longest chain. So whenever you have an alkane, you normally choose the longest chain, and you name it. Hapt means that the longest chain is 7 carbons. Now the ending is called suffix, and that ending is going to tell me what type of functional group I have. Now I know alkanes are not functional groups, but the representation for the alkanes is A and E at the end. For example, the representation of alkenes is E and E at the end. For the representation of triple bonds is Y and E at the end, which is alkyne. So the ending of the name is going to tell me what type of functional group I have. So this is very important. What precedes that is how many carbon chains do I have in my structure. What precedes that is my structure having any branches, and where are the branches located on which carbon? There are certain things in organic that you need to memorize, you guys. One of those is this table over here. Some of the students made a song out of it. I don't know the song, but just be creative. Here you go. 1 carbon is methane. 2 carbon is ethane. So notice the ending of the A and E at the end for each one of those. So meth, eth, prop is 3 carbons, bute is 4, pent is 5, hexane, heptane, octane, nonane is 9, decane is 10. And then you go on, do, Un is for basically 11. Undecane. Decane is 10. Un is 1. So this is going to be 11. Do means which means 2. So 2 plus 10, this is 12. Then tridecane, tetradecane, pentadecane with 15. And then all the way to icosane. I didn't write the rest over here. This is going to be hexadecane. So hexa stands for 6. Heptadecane, octadecane, nonadecane, and then icosane. Icosane is 20. We're going to stop at 20 in there. Now, if you have any carbon coming off the chain, this is called a substituent. So let's say, for example, if I have a long R chain, a long carbon chain, and then one carbon coming off the chain. See that carbon over here is called a substituent. And to name that carbon, we're going to name it as an alkyl group. As you can see, this carbon is a CH3. So it's basically a CH4 minus a hydrogen. So if you remove a hydrogen, it will be a CH3, and that will be connected to a long carbon chain. This is the long carbon chain in there. In that case, you would name that as an alkyl. So you check how many carbons is that substituent, and then you name it accordingly. So if it was one carbon, then it's going to be methyl. See the ending YL over there? It tells me that it's a branching off the long chain. 2 carbons is an ethyl, 3 carbons is a propyl, 4 carbons is a butyl, and as you go. So the ending, you drop the ANE and we put YL. So instead of decane, it will be a decyl in this case. There are certain groups that for simplicity, we name them as basically as a group. Like for example, if you have this structure over here where you have 2 CH3s connected by a CH, this is called iso. And count the carbons, this is 1, 2, 3, it's called an isopropyl in there. Now see all of those names that you see? These we call them common names. They invented this way to name certain groups as a bunch, as a whole, instead of naming them individually. So in this case, I'm having 2 carbons connected to a CH. Basically the skeletal form for it is this. This is called an iso. So that structure here is an iso. And now you count the carbons that are connected to it. So they are connected, or the carbons that are connected to that is a 3. So this is called an isopropyl. Okay. Now, if I have 4 carbons, if I have the connection now here, so now I do have 4 carbons over here, I still have my iso structure in here. See? So that is going to be now iso. But how many total carbons you have? 1, 2, 3, and 4. So it's going to be an isobutyl. Okay? This is basically the skeletal form. This is the condensed structure for the isobutyl. And then you have a secondary butyl. We're going to talk about all of those in details, but just explaining. A secondary butyl over here is when the butyl chain is connected to its second carbon. This is carbon 1, this is carbon 2. It's connected to the second carbon, or from its second carbon to the longest chain. This is called a sec-butyl. Secondary butyl. Sec is not part of the name. So this is why we put a dash between the sec and the B and the butyl. So when it comes to alphabetizing, you have to look at the B because secondary is not part of the name. And then if you have a structure, sec-butyl looks like this in the, okay, so this is secondary butyl. In the skeletal form, it's connected to its carbon number 2. So it's a butyl chain, but instead of the connection being at carbon number 1 to the long chain, it is on carbon number 2. And then we have tertiary butyl. Tertiary butyl is when you have 3 carbons, the 3 CH3s coming off a C. So this is called a tertiary, T-E-R-T, and a butyl, tertiary. Again, like sec, they are not part of the name. So when it comes to alphabetizing, you have to look at the B. I either write it as tert or as a T over there, and both are going to be the same. ISO, the difference between sec, tertiary, and ISO, these are their structures and they're in skeletal. You can see the difference between the three of them. But when it comes to alphabetizing, ISO is part of the name. So I is looked at whenever I am alphabetizing. You look at the I, you don't look at the B, because I is part of the name. But the S in the sec and the T in the tertiary are not part of the name. So you drop those and you look at whatever precedes whatever alkyl chain you have. There are certain substituents also that I want you to know. This is another table that I want you to get familiar with, and you will get familiar with as you practice more problems in there. Now, for us, with respect to this chapter, we're going to limit ourselves to the halogens. Whenever they are coming off the alkane chain, how to name them. So fluorine, if you have fluorine coming off the alkane chain, you name it as a fluoro, iodo, bromo, chloro for the Cl. If you have a cyanide coming off the chain, then you name it cyano. If you have, let's say, if you have an SH coming off the chain, you name it as a mercapto. If you have an NO2 coming off the chain, you name it as a nitro. If you have a carbonyl coming off the chain, that is named an oxo. Now, with respect to those, the oxo, the carbonyl, which is the aldehyde here, the formyl, the acetyl, and the phenoxy, the alkoxy, all of those, we're going to learn those as we proceed. So they are not going to be showing in this chapter. Same thing if you have NH2 coming off the chain, you name it amino, OH, you name it hydroxy. So all of those are not going to be showing in this chapter. Even these also, they are not going to be showing in the chapter. What's going to be showing in the chapter here is any of the halogens if you have on the alkane chain, then you would need to know how to name those. If you have a CN coming off the alkane chain, you need to know how to name those, okay? Another table that I want you to know, get familiar with, because we will hit on this soon once we start alkenes. If you have a carbon double bond carbon coming off the chain, as you notice over here, I always put a bond. What does this bond mean? And then a line like this. This bonds mean that this is a substituent coming off along a chain. So you have a long hydrocarbon chain, and on that hydrocarbon chain you have this group. Then in that case you name it a phenyl. If you have, this is a long, again, long alkane chain here, and on it you have this group, then you will name it as an allyl. An allyl is an alkene that is connected to a carbon. And then a benzyl is a benzene that is connected to a CH2. And then a phenyl is a benzene that is directly connected to a long chain. See the difference between both? A benzyl is a benzene connected to a CH2 and then a long chain. A phenyl, no, there is no CH2. The benzene is directly connected to the long chain. Let's explain in details the term isotertiary and secondary. It's really the way how the carbon chain is connected, or the substituent is connected to the chain. If you look at a chain of 3 carbons, there are 2 types of hydrogens in there. There's a secondary hydrogen and there are primary hydrogens. So if the connection is from the primary carbon to the long chain, this means that I am basically connecting. See, this is going to be my primary carbon. So if my primary carbon is connected to the long chain over here, then I'm going to call this a propyl group. So the whole thing will be called a propyl group, and that will be connected to the long chain. If the connection to the long chain is from the second carbon, this is 1, this is 2, this is carbon number 2 of this structure in here. So if the connection is from the second carbon, meaning that I removed 1 secondary hydrogen, then I'm going to call this an iso. You guys, as I mentioned, an iso has a skeletal form of 2 CH3s connected to a CH, and the whole thing is connected to a long chain. This is called an iso group. So to know exactly how much carbons you have, count the number of carbons. We have two types of iso. We have an isopropyl and we have an isobutyl. So this is going to be the isobutyl over here. The isobutyl comes from isobutane. So if I lose, or if I do the connection from the primary hydrogen over here to the long chain, this is the connection, then that is going to be called an isobutyl, because all of the carbons here are 4, count them, they are 4, and I have the isostructural unit in here. This is the isostructural unit. So you have the isostructural unit in there. So if you have a chain of 4 carbons, chain of 4 carbons is called a butane. If that chain of 4 carbons is connected to a long chain, I'm going to name it in a form of an alkyl group. So it's 4 carbons, so it's going to be a butyl group. So if it's connected to carbon number 1, then it's going to be a butyl group of the chain. If basically there is a branch in there and it's connected to its primary carbon to the long chain, then I'm going to call it an isobutyl group. If it's connected to its carbon number 2, which is the secondary carbon, notice this carbon here is a secondary. Why? Because it's connected to 2 carbons. Okay, I don't count the carbon of the long chain. So that, because I'm naming this as a substituent on its own. So this carbon over here is connected to 2 carbons, so it's a secondary carbon. So if the connection is from the secondary carbon, then that is called a sec-butyl group. And if the connection is from the tertiary carbon, we still have 4 carbons in there. It's still a butyl, but now it's going to be tertiary. So the point is, the butyl group can be arranged into an isostructural unit, a sec structural unit, and a tertiary structural unit. And then you have the term neo. Neo, we don't use it much, but neo is for 5. So neo stands for 5. It's the arrangement of 5 carbons in there. So how 5 carbons arranged? This is the structure of a neopentane. This is pentane. Iso is whenever you have the isostructural unit. So this is going to be the isostructural unit over here. This is the isostructural unit. However, let me erase this. Okay. If you have 5 carbons in there, then you would need to add 2 more carbons. So this is it. And then you will have the connection to the long chain. This is my iso. So I'm going to name this an iso. And this is 1, 2, 3, 4, 5. So it's going to be an isopentane. Pentane, if it's this structure. If it's connected to a long chain, it's going to be an isopentyl. Neo is whenever you have a carbon in the center surrounded by 4 carbons. So if that is connected to a long chain, you drop the A and E and you name it as a YL. So it's going to be a neopentyl. A YL means that the structure is connected to a long, it is a substituent of the long coming of the long chain. So let's start with the rules of how to name alkanes. The first thing you do, you choose your longest chain. Your longest chain, whenever you want to choose it, you have to start from one end. Whatever end you pick, it's fine. It's okay. It's fine for now if you don't have substituents. But you're going to start from one end and keep going until you figure out the most carbon chain you can get out of your structure. So we're going to find the longest carbon chain. That needs to be a continuous long chain. It doesn't matter if you go straight. It doesn't matter if you bend. It doesn't matter. Here, see, I'm starting from one end. Either of these ends, it's okay when counting the longest chain. I'm not naming it yet. I'm just counting the longest chain. So start from one end and keep going all the way until you figure out the longest carbon chain. It doesn't have to be straight. This is why I'm giving all of these examples in here. This is the first thing. So find your longest chain. Once you find your longest chain, name it. So here I found that my longest chain is 8 carbons. If I go this way, it's 8 carbons. These two are the same structure. If I go this way, so going this way here, it's 7 carbons. 8 is more than 7, So this is why I go with the longest carbon chain, put the name. 8 is an oct, and then the ending is ane, so octane. Octane goes at the end of the name. So now I know that my parent name is octane. Now I need to name the substituents in there. Before naming the well, basically I need to highlight the substituents. Figure out how many substituents you have. There is a rule in there. Whenever you have two options of basically having a chain, if you have two chains that have the same length, as in this example over here, these two are the same structure, and I can point out 7 carbons out of each over here. So I can go this way and make 7 carbons, and I can go this way and make 7 carbons. Which way should I go with? The rule says that if there are two chains of the same length, you need to pick the chain with the most substituents. So if I go this way, I will end up having 2 substituents coming off my chain. If I go this way, I would end up having one large isopropyl substituent coming off. So one substituent versus 2 substituents, then I would go with the most substituents. So this is why you pick always a chain that has the most substituents if you are in a way that you have basically 2 chains that have the same length. Step number 2, you have to now number your substituents, and you have to give the lowest number to the first substituent, because there are 2 ends that we can start numbering. This end, we can start numbering our chain from this end, or we can start numbering our chain from this end. Which end is it gonna be? Well, you have to choose the end which is closer to the first substituent. So this for this way over here, I'm starting my chain with numbering this carbon on this side. The reason why, because the CH3 is closer to carbon number 1, it's on carbon number 2. This is going to be my first substituent. Here my first substituent is carbon number 3. So always give your first substituent the lowest number. If you have 2 substituents, or if the first substituent is at the same distance from both ends, see this example here, I have my first substituent. If I start on this side, my first substituent is on carbon number 2. If I start from this side, my first substituent is on carbon number 2. So if the first substituent is on the same carbon, or is at the same distance from both sides, then in that case you need to look at the second substituent and give the second substituent the lowest number. So here my second substituent, if I start from this side, my second substituent is on carbon number 3, but here my second substituent is going to be 1, 2, 3, and 4 is going to be on carbon number 4 if I start numbering from that side. So this is why I cannot use this way. I cannot start numbering from this side here. I have to start numbering from the other side, from this side. Now, when numbering the carbon chain normally results in the same numbers from either end, then in that case you have to arrange the substituents alphabetically and give the lowest number to the first substituent that basically comes, or the lower number alphabetic first substituent. So here in this case, my substituent is an ethyl. I have another substituent which is a methyl. Now both substituents are going to be at the same, they result in the same number at either ends, because the ethyl, if I go this way, the ethyl is going to be on carbon number 3, and the methyl is going to be, if this way, the ethyl is going to be on carbon number 3, and the methyl is going to be on carbon number 5. And if I start numbering from this end, then the methyl is going to be on 3 and the ethyl is going to be on 5. So the numbering is going to be the same in this case, 3, 5, 3, 5. So in that case, I would need to assign the lower number alphabetically to the first substituent. So E comes before the M, so E takes the lowest number. Then you need to number your substituents in there. You name your substituents as an alkyl group. So the CH3s, this is a CH3, CH3, this is a CH2, CH3. So the CH3s are methyl, so you name it as an alkyl, as we said. So you drop the A and E and you put YL. So one carbon is methyl, two carbons are ethyl. So I have two methyls and one ethyl in there. Each carbon belongs to either, so each carbon in here in the chain and in the substituent. So these carbons, they belong to the substituents. These carbons in the chain, they belong to the chain. They don't belong to the substituent. So I already named them as octane. Now the carbons that I am circling, these carbons, they belong to the substituent. Each carbon of these substituents need its own number because I want to know where they are in the chain. If two or more identical substituents they are bonded to the longest chain, as in this case I have two CH3s, then I need to use the prefixes di, tri, tetra, and each of these CH3s get their own number. So now when I want to name them, this is going to be, I know that I have two CH3s, so it's going to be dimethyl. Where are the dimethyl? I have two of them, not one, two. So I need to represent them with two numbers. They are on carbon 2 and carbon number 6. So I put 2, comma, 6, and dash. Between numbers, you put a comma. Between a number and the letter, you put a dash. As much substituents as you have needs to be equivalent to the numbers that you have in front of these substituents. So you have two substituents here, you need to have two numbers. Three substituents, three numbers. Each substituent gets a number. I cannot do 2,6-methyl. It's not right because methyl is one substituent. How am I getting two numbers in here? It's not right. Okay. And after you do this, you need to arrange them in alphabetical order. To arrange them in alphabetical order, normally we ignore the prefixes di, tri, tetra, penta. We don't look at those, so we look at the M and we look at the E. The E comes first, so it needs to come first in the naming. So that is going to be on carbon number 5, I have an ethyl. Between the number and the letter, normally there is a dash. Between the two numbers, there's a comma. So you start with 5-ethyl. E comes first, you arrange them in alphabetical order. 2,6-dimethyl, you don't look at the D in di, you look at the M in the methyl. So 5-ethyl, 2,6-dimethyl, and then octane. So the name is like this. There are no spaces between the substituents and the parent name. They are all one name. Normally we ignore all the prefixes, so the di, tri, tetra, penta, you ignore them. As I mentioned before, secondary and tertiary, they are not part of the name, so you ignore those. You look at the letter after the sec and the tertiary. But you have to alphabetize iso, because iso is part of the name. You have to alphabetize neo because neo is part of the name. We will talk about the cyclo in there. Cyclo is part of the name, and we will talk about it once we start naming cycloalkanes. Okay. So let's have an example in there. Before having this slide, before showing you the slide, let me jump here. Okay. So these are examples in here of how to name alkanes, and you have more examples also in the practice problems. So the first thing that you would need to do is choose your longest chain. I can go this way, I can start this from this end here, I can start from this end in here. So let's go ahead and see. If I start from this end coming 1, 2, 3, 4, and 5, this is 5 carbons. If I go 1, 2, 3, 4, 5, 6, this is 6 carbons. So here you go, this is going to be my longest chain. On my longest chain, I do have a substituent, which is a CH3. Circle those as I am doing. And then start numbering it from the end that gives the first substituent the lowest number. So your numbering is going to be from this end. I have on carbon number 3 a methyl. This is my only substituent, so the name is going to be easy. 3-methyl, and then the parent name is hex, and the ending is A and E. Notice there is no space between the methyl, the substituent, and the parent name. Same thing over here. You start with your longest chain. See, my longest chain is here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my longest chain. So that is going to leave me with an ethyl as a substituent, a methyl as a substituent, and another methyl as a substituent. Write them down. This is an ethyl, this is a methyl, and this is a methyl over here. Notice how I writing the substituents. I didn't say methane, I said the methyl, because this is an alkane. It's an alkyl coming off the chain, so I have to name it as an alkyl ending in YL. Any carbon or carbon chain coming off the long parent chain, that has to end in a YL. You don't have any other option. Then you arrange those in alphabetical order. I know that E comes before. Okay, so E is going to be at the beginning of my name. It doesn't have to be the lowest number here in this case, but it has to be at the beginning of the name. Now, numbering those substituents has to do with the position of the first substituent from either ends of the chain. I need to number it in a way to give my first substituent the lowest number. Here, my first substituent, notice, my first substituent is an ethyl if I start numbering it from the side. Here, my first substituent is a methyl if I start numbering it from this side. An ethyl is on carbon 3, a methyl is on carbon 3. So since both of them are at the same end, they are basically present at the same number from both ends, what I need to do is I need to give the lower alphabetical letter the lowest number. So in this case, the ethyl gets the lowest number, so I have to start numbering from the side. It's going to be 3-ethyl. Now the CH3s are 2, right? 2 of the same kind. I'm going to group them and put di. And since I did put di over here, then I need to have 2 numbers in front of that. Carbon 4 and carbon 7, I need to specify. Between the numbers, there's a comma. Between the letter and the number, there is a dash. There are no spaces between the substituent and the parent chain. Please practice how you write these names correctly, how you spell them correctly, okay? So let's do one more. So over here, my longest chain, see how did I go here? This is 1, 2, 3, 4, 5, 6, and 7. If I go this way, it's going to be 5, 6. So if I go that way, it's going to be 5, 6, 7. It's still the longest chain in here. So that is going to leave me with 2 substituents, a CH3 on carbon 3 and an ethyl group on carbon number 4. If I start numbering from this side, giving those 2 the lowest number. So arrange them in alphabetical order now. E comes before the CH3. The CH3 gets carbon 3. The ethyl gets carbon 4. And you simply put the name together. Okay. Let's do this one over here. Okay. So doing this one, I have 10 carbons. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here you go. So this here, this is my longest carbon chain. If you go any of the other ways, that is going to be your longest of 10 carbons. This is going to be decane. Decane is at the end. Now with respect to the substituents, circle the substituents. I have 3 ethyl groups. So notice in my name, it's going to be tri-ethyl. 3 ethyl groups. So this means that I need to have how many numbers before the ethyl? 3 of them. 3 of them. And then give the first substituent the lowest number. So I have to start numbering from this side over here. 1, 2, and 3. 4, 5, 6, and 7. So that is going to be 7, 7 methyl. So 7 methyl in there. 3, 6, 6 triethyl. and then 7-methyldecaine. Why this is before the methyl? Because the E comes before the M. The E in the ethyl comes, so the E in the ethyl comes before the M in the methyl. You have to arrange them in alphabetical order. Don't look at the prefix and try. Now let's say if I have a complex substituent coming off the side of the chain. Something like this. See, my longest chain in this example is 11, a chain of 11 carbons. Okay, this is my longest chain in there. So the ending is going to be on decane. I have two substituents. I have a methyl substituent coming off the chain on carbon number 2. And then I have, see that bulky group over here, that big group. This is called a complex substituent, a branched chain coming off the long chain. It's no longer 2 carbons or a 1 carbon or a 3 carbon. No, it is a branched chain coming off the long chain. So how do I need to do it? This is called a complex substituent. You name it in any of the two ways. If it's one of the common names like the tertiary butyl, the isopropyl, the sec-butyl, then you name it as a sec-butyl if you want. This one over here is a sec-butyl. This is a 1, 2, 3, 4 carbons, and the attachment basically to the long chain is on carbon number 2. If I start numbering from here, this is 1, 2. So the attachment is on carbon number 2 of the chain. So this is called a sec-butyl. So I can name it as a sec-butyl, and if I name it as a sec-butyl, then the name is going to be 4 sec-butyl. Remember, sec is not part of the name, so I have to look at the B. This is why I put it at the beginning, because B comes first compared to the M in the methyl. Then it's going to be 2-methyl. And then the name is going to be on-decane. This is one way of naming it. Okay? Another way. And the other way is normally used in the IUPAC system. Instead of naming that whole group as a sec-butyl, as one name, I'm going to break it down. So you start with locating that complex substituent where it is on the longer chain. It is on carbon number 4, right? So you put 4, you put a dash, you open a brackets. Now I want to name this small substituent as its own alkane chain. The same rules that I used in order to name that long alkane chain, I'm going to use it to name that branch in here. So you start with, see how am I doing my connection? The connection to carbon number 4, so your first connection is carbon number 1. It's always that case. So whatever carbon is connected to carbon number 4, this is your connection in there. That is going to be carbon number 1. And then you have two options. Remember here when I said that choose your longest carbon chain, choose your longest carbon chain. This is the same thing. So you start with your connection, locate your connection to the longest chain. My connection is on carbon number 1 here. Number 1 is connected to 4. 4 is basically on the chain. And then I can go either ways. I can go this way or I can go this way. You need to choose the longest carbon chain way. So if I go this way, I have 1, 2, 3 carbon chain. So my chain is going to be propyl in this case, 3 carbons. If I go this way, then my chain is going to be 2 carbons. It's going to be 1, 2. It's going to be an ethyl. A 3 carbon chain is more than a 2 carbon chain. So this is why I need to go this way. This is my longest carbon chain. This is going to make that CH3 over here. So it's going to make this CH3 a substituent coming off the long carbon. So this is going to be my long carbon chain of that substituent, and that CH3 is going to be coming off the chain. So I'm going to name it as a small chain substituent in this case. Exactly the same rules as I use in order to name that long chain. To name the long chain, you choose your longest chain and then name the substituents. Arrange them in alphabetical order. Same thing here. I'm going to choose my longest chain and I'm going to name my substituent. Arrange them in alphabetical order. So my longest chain of this small subchain is basically prop. But since I cannot say it's a propane because I reserved the ending of the A and E to the parent, to the longest chain. This is a substituent coming off the chain, and any substituent coming off the chain has to end in a YL, any of those. So this is why it's now a propyl. So when I look at it, I would know that this guy over here is a substituent of that long chain. So it's a propyl, and off the propyl on carbon number 1, I have a CH3 coming out. It's going to be 1-methyl propyl, 1-methyl propyl. And all of those are coming off carbon number 4. Now, when I arrange this in alphabetical order, the M's are the same over here. So I need basically to check the M versus the P. So methyl comes before the P. So this is why I started here with 2-methyl. On 4, I have all of this complex group. And then I have an undecane, which stands for 11. Let's have an example over here. Okay, so let's have an example here. Let me use this color over here to choose the longest chain. So my longest chain, let's go ahead and see if I start from this end. 1, 2, 3, 4, 5, 6, 7, and 8. I have 8 carbons. If I go here, 1, 2, 3, 4, 5, 6, 7, 8. So I can go this way. I can go this way. It doesn't matter. It doesn't matter because both have CH3s at the end. So I can go either this way. Let me highlight it. I can go either this way or I can go this way, and both are the same because these two CH3s are the same. It doesn't matter this way. Okay? It doesn't matter. I'm going to go this way here. Now choose your substituents. I have a CH3 as a substituent, and I have all of this complex substituent coming off. I know this complex substituent is an isopropyl. I is part of the name. So in this case, I need to arrange them alphabetically. I comes before the CH3, but the CH3 is closer to this end. This is going to be 1, this is going to be 2. 3, 4, and 5. So this is going to be 5 isopropyl, 2-methyl, and octane. This is a chain of 8 carbons. This is one way of naming it. And normally I would specify in my question that you are allowed to use the iso, the tertiary, and the secondary in your naming in the IUPAC naming. If I told you you're not allowed to use those, then you have to name this as a branch coming off carbon number 5. So you do carbon 5 as we did before, you open a brackets. Now, the first carbon that is connected to carbon number 5, I'm always going to give it carbon 1. And then you go and you choose the longest chain from either of the sides. It doesn't matter because if I go this way, it's 2 carbons. If I go that way, it's another 2 carbons. So I'm just going to choose this way over here. Let me use another highlight. This is my longest carbon chain, and that CH3, see that CH3 here, is coming off the long chain. So I'm going to name this as 1-methyl and an ethyl. So it's going to be 1. On carbon 1, I have a methyl. And the longer chain is going to be an ethyl. All of them should end in a YL to tell me that all of those are substituents that are coming off octane. Where? On carbon 5. See, if you drop 5, if you did not add 5, I won't know where this group is on the 8 carbon chain. It's an 8 carbon chain. It can be anywhere. So pay attention to that. Arrange in alphabetical order. That is going to be 2-methyl, 5, 1-methyl, ethyl. Oh, by the way, I should have written this in another. Okay. Let me go ahead and erase this. I didn't put them in alphabetical order, so it has to be 5. It's going to be 5. It's going to be 1-methyl, ethyl, close, and then dash, and then on carbon number 2 I have a methyl. See, that comes first because E comes first. And then my longest carbon chain is octane. So this is octane. There is no space between the methyl and the octane. Okay. So this is basically how to name alkanes. So let's go ahead and do this example. Give the IUPAC name of the following hydrocarbon. Convert the drawing into a skeletal structure. So these are condensed. This is basically the molecular model. This is what you see normally in your AL homework. A molecular model, you have to convert it. So let's go ahead and convert. I'm going to convert it directly into a skeletal form. It's easier. So this is a CH3, this is a carbon, CH3, this is a CH2. Okay, this is a carbon, it's a C, no hydrogens. It has 4 carbons around it. It has 2 CH3s coming off. These are the 2 CH3s. And then I have another carbon here. This is my carbon. Going this way, I have a CH. This is a CH. On the CH, I have an ethyl group. This is an ethyl group. And here I have a methyl group there. Okay. There's a hydrogen in here. You don't have to show the hydrogens. And then we are missing a carbon. This is basically the CH3. This is my CH3 here. This is the CH3 there. So this is going to be my skeletal form. Now let's go ahead and choose the longest carbon chain. My longest carbon chain in this case is 1, 2, 3, 4, 5, 6, and 7. Let's see if I can get more. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6. No. So this is going to be my longest carbon chain. Highlight it. Okay. Now after you choose your longest carbon chain, now name your substituents. On carbon number 3, I have 2 methyls in here. On carbon number 3, I have an ethyl. See, the 2 methyls are 2 substituents getting a lower number. Here, 1 substituent getting a lower number. So I have to start numbering from the side. This is 1, 2, this is a 3. This is 4, this is 5, and this is 6, and this is 7 over here. So my ending is going to be heptane. This is my ending. On carbon number 3, I have 2 methyls, 4, I have a methyl, and 5, I have a methyl. So how many total methyls you have? Combine them together. It's 4 of them. So it's going to be a tetramethyl. So it's going to be 3, 3. Notice what I did over here. 2 methyls on carbon number 3. I didn't put just 1 3 number. No, 2 numbers. 3, 3. And then 4. And then 5. I go from the lowest number to the highest number, and that is going to be tetramethyl. Okay, it's going to be tetramethyl and then heptane. Tetra stands for 4, so I need to have 4 numbers. If I had a 3 here, then I need to have 3 numbers. The numbers need to correspond to the number of substituents. Okay? So these are my substituents, so just go ahead and circle them. We're going to do the same thing in here. Normally, I like to change any condensed, any structural formula into a skeletal because it's easy when you name it. So I have my iso group. This is my iso group over here. I'm having my CH2. This is going to be my CH2. My CH that basically has the 2 CH3s over here. So let me draw it in a better way. Here you go, just show you that CH2 carbon, and then here you go, these 2 carbons here. Okay, now when you choose your longest chain, go ahead and highlight. It's gonna be 1, 2, 3, 4, and 5. This is the most I can get out of it. So it's a 5 carbon chain. 1, 2, 3, 4, and 5. Numbering from this side or this side, it doesn't matter because both sides are going to give my first substituent carbon number 2. So I'm having here 2, 4 dimethyl because I have 2 CH3s over there, and it's going to be pentane. With this one over here, I have a tertiary butyl group. So notice I didn't name it as an iso because it's part of the long chain. I used its carbons to make the long chain, so it's no longer iso anymore. So this is going to be my tertiary carbon over here. See, this is going to be my it's actually my quaternary carbon, because this carbon over here is connected to 4 carbons. And then I have my CH2. This is going to be my CH2. Another CH2. This is another CH2 here. And then I have a CH. This is my isopropyl group over there. Now highlight your longest carbon chain or R chain. This is going to be it. 1, 2, 3, 4, 5, and 6. So it's going to be 6 carbons. So it's going to be 1, 2, 3, 4, 5, and 6. Notice I started numbering from this end because on carbon number 2 I have 2 methyls. Here, if I start numbering from this end on carbon number 2, I'm going to have 1 methyl. So it's going to be 2, 2, and then 5. And tri-methyl, and then hexane. This is to name alkanes. Now to name cycloalkanes. We're going to use the same rules for naming. Everything is going to be the same. The naming of the parent is going to be the same, but instead of naming it as a straight chain, we're going to name it as a cycle. So to name it as a cycle, you're going to have to put the word cyclo in front of the parent name. So instead of, this is a pentane, it's a 5 carbon cycle. 5 carbons is pent. So instead of saying pentane, you put cyclopentane. You guys, if you do pentane without a cyclo, then this means that the 5 carbons are arranged in a chain rather than a cycle. So a cycle of 3 carbons is called cyclopropane. A cycle of 4 carbons, this is cyclobutane. And then a cycle of 5, cyclopentane. A cycle of 6, this is a cyclohexane. And as you go, okay? I've shown you here basically the skeletal form. This is how normally we represent the cycles in a skeletal form. It's easier than representing it in their structural formula. So this is the structural formula for the cycles. This is their skeletal form, and this is the way that we represent them. A cycle has a molecular formula of CnH2n. As I said, the degree of unsaturation is 1 for the cycles. So it has 1 degree of unsaturation because it has a cycle in it. Now, how to name the cycle? First of all, you would need to find the parent cycloalkane. The parent cycloalkane is the cycle that has the most numbers. It's actually 1 cycle. So you're going to highlight it, and that is going to give it the parent name according to how many numbers the carbon cycle is. This is 6, so it's going to be a cyclohexane. Now, if you have a cycle that has 1 substituent coming off, that is easy because you can name that substituent and put it in front of the parent name. So this is a 1 carbon, it's going to be a methyl. Okay, all of this here is going to be a tertiary butyl. This is a tertiary butyl because 1, 2, 3, 4. So you have 4 carbons in there. They are arranged in a tertiary butyl. I can name it as a common name in that case. So it's going to be called tertiary butyl cyclopentane. If I say, or if the instructions in the exam says that do not use tertiary, iso, and secondary, then you have to name it as a complex substituent. And to do this, we're going to use the same rules as we did before. The carbon that is connected to the cycle, we're going to number it carbon number 1, and then go with either directions to choose the longest carbon chain. It doesn't matter because in both directions my longest carbon chain is going to be 2. Okay, so I'm going to go this way over here. So going this way, that is going to make this my longest carbon chain, and on the longest carbon chain, it's going to be 1, 2. There are 2 CH3s coming off the chain. Okay, so that is going to be basically 1, 1 dimethyl, okay, dimethyl ethyl, okay, and then you can put the whole thing in brackets if you want, but here in this case you don't have to. The reason why, because this is the only substituent coming off the cycle. So you don't have any other substituent in there. So immediately it's given carbon number 1. So you can say like this, you can do 1 dash the whole thing and then cyclopentane, or Okay, normally we don't do this because it's just one cycle coming off the chain of the or one substituent coming off the cycle. Normally we don't do this. We don't show the one in there. You can drop it. You can take off the brackets in there, and it's gonna be 1,1-dimethyl ethyl cyclopentane. There is no space between any of those. So if I did a space, it's my mistake in here. There are no spaces, so you have your cyclopentane directly attached to the ethyl. This is a cyclopentane. Okay, whenever you have one substituent coming off the cycle, you don't have to number that substituent. So you don't have to say that that substituent is on carbon number 1 of the cycle. So I don't have to say this is a 1-methyl cyclohexane, because see that CH3 in here can be anywhere on the cycle and it can still be on carbon number 1. Let me give you an example over here. This is the cycle. I can put the CH3 here. I can put the CH3 here. I can put the CH3 here. I can put all of them are the same, okay? I can put the CH3 here. Anywhere on the cycle, that CH3, it's still gonna be numbered 1. So no need for me to say 1-methyl cyclohexane. Point is, if you have one substituent coming off the cycle, then you drop the 1. You don't have to put 1 in there. You don't have to number it. Just name that substituent and name the parent chain. If you have two substituents coming off the cycle, now you have to number. Now you have to number. And you have to give your substituents the lowest number. And normally we go with the first substituent needs to get the lowest number, and then the second substituent as you go. Or we say that we give the substituents the lowest sum of numbers. Whatever method you want to go with, it's fine. Let me give you an example in here. You have the 2 methyls in there, 2 CH3s. So the first CH3, you start numbering it. So I'm gonna start number from either one of those. I can give that CH3 carbon 1 or that CH3 carbon 1, it doesn't matter. But if I start numbering from either one of these carbons, then I need to give the second substituent the lowest number. So I need to go with in a way or in a direction to give the second substituent the lowest number. So if I start numbering 1 here, I don't go this way and say 1, 2, 3, 4, 5. No, that carbon will be 5. It's not right. So I need to go this way in this direction and give my second substituent the lowest number in there. So it's going to be 3. So the name will be 1,3-dimethyl cyclohexane. When two different substituents, if you have two different substituents, methyl, ethyl, then in that case, I want you to assign the lowest number to the first alphabetical substituent. E comes before the M, so E takes the lowest number. You don't guess in here. There are no guessing in naming. So if you have two different substituents, please number the ring to assign the lower number to the substituents alphabetically. So now my name is going to be 1-ethyl 3-methyl cyclohexane. Okay, so this is it. Okay. And then if there are more than 2 substituents, then in this case, I want you to list them in alphabetical order. And I want you to count in the direction that gives the lowest numerical sum. Have an example. So I have here a propyl. I have an ethyl. And I have a methyl. Good? Okay. I know that the E comes before the M. And then the P last, right? But it's not necessary that the E gets the lowest number in this case. I need to number them in a way to give the lowest sum of numbers. So let's say, if I start numbering from the propyl, if I give a propyl 1, then the closest substituent to the propyl is the CH3, which is 2. Then I have 3, then I have my ethyl is gonna be 4. So I'm going to have a combination of 1, 2, and 4. Okay? Let me use another color over here. If I start numbering from the CH3 now, So that is going to be 1. My closest substituent to it is going to be the propyl. This is going to be 2. This is a 3. This is 4. And this is 5. So my combination here is 1, 2, and 5. See what I'm saying? You give the lowest sum of numbers. So till now, this is my lowest sum. Let's use another color here. So if I start numbering now from the ethyl, this is going to be 1. My closest substituent to it is the CH3. This is going to be 3. And this is going to be 4. So I have 1, 3, and 4. See? Again, I need, so from all of these choices, starting from here, or starting from here, or starting from here numbering, this is going to be my lowest sum of numbers. So this is why I went by it. You go by that, and then you arrange them in alphabetical order. This is an example over here again. Okay, this is my cyclohexane, ending cyclohexane. Now this is a complex substituent. This guy over here is a complex substituent. It's a secabutyl. It's on carbon number 1, so I can name it as 1 secabutyl, and then 2, 3, and this is a 3, and this is a methyl in there. The reason why I went with the secabutyl to be in carbon number 1, because when you have two substituents, you have to give the lowest number to the first alphabetical substituent. The first alphabetical substituent is the B in the butyl, so this is why that guy took carbon number 1 on the benzene, or number 1 on the cycle. I'm sorry, not the benzene. Okay, so this is one way. Another way, if I tell you don't use secabutyl, please name it as a complex substituent, then the name is going to be, in that case, let me erase. Okay, the whole thing is connected to the cycle to carbon number 1, right? Because these are two substituents in there. I still need to put them in alphabetical order. So that is going to be 1. So I'm going to do 1 and open the brackets. So I'm going to do 1 and open the brackets. Now this is going to be carbon number 1 here. I'm going to choose the direction that I'm going to go by, and I'm going to go this way because this way is going to give me more carbons in my chain. So that's going to be propyl, and I have a CH3 coming off the propyl. So it's going to be 1 methyl, 1, 2, 3, 1 methyl propyl in this case. 1 methyl propyl. All of those are on carbon number 1. And then I do have a CH3 in this case. This is going to be my methyl. So it's going to be a 3 methyl. You guys, this comes before this one. So I'm going to change my numbering here. So instead of having this guy to be on carbon number 3, now it's going to be on carbon number 1, and this is going to be on carbon number 3. So we're going to change our numbering in this case, and the name is going to look like this. The name is going to be 1 methyl. I don't have enough space in here, but you shouldn't leave that. Here you go. I'm going to write it over here, 3 on carbon 3. So it's going to be 1, 2, and 3. On carbon 3, I have 1 methyl propyl. And the reason why I did put the methyl before the methyl propyl, because that comes alphabetically before the P. M comes before the P. So I have 1 methyl, 1 methyl propyl, 3 methyl propyl, and then it's going to be cyclohexane. Okay, here I am naming that this is a cyclopentane, and on the cyclopentane I have 3 ethyl groups. So you need to give them the lowest number in this case. So starting from here, I have 1. This is on carbon number 1, 2. Okay, if I go by 1, 2, 3, 4, so I have 1, 3, 4. Okay, or I can go by, so 1, 3, 4, or 1, 2, 3, 4. So 1, 2, 4. 1, 3, 4 or 1, 2, 4. 1, 2, 4 is the lowest combination of numbers. So this is why I go with 1, 2, 4. 3 of them. So I have to have 3 numbers. And this is going to be tri. Please don't forget the prefix in there. So this is going to be tri and then ethyl cyclopentane. Okay. This is another example in here. Naming this as a complex substituent. That is going to be carbon number 1. Okay. It's carbon number 1, and this is going to be on carbon number 3 of the cycle. So it's going to be 1 methyl here, 3, open brackets. On carbon number 1, I do have, this is my longest chain, and off the longest chain, I have 2 R groups coming off that. This is going to be my 1, 2, and the 3 over there. It's going to be a propyl. And then I have 1, 2, 1, 2 dimethyl propyl, and then cyclohexane. Notice when I have 2 same groups coming off a carbon, then in that case they have to have the same number twice. So this is going to be 1, 1, and this is the lowest sum of numbers here to start numbering from this carbon, because you have 2 CH3s to give them the lowest number possible. So it's going to be 1, 1, 2. I didn't say 1, 2 trimethyl. It's not right. 2 numbers, 3 substituents. This is not right. You need to have your numbers in there, needs to be equivalent to the number of substituents that you have. Okay, naming alkanes versus cycloalkanes, this is very important. So now if you have a cycloalkane and an alkane chain, now the rule says if the number of carbons in the ring is more or is equal to the number of carbons in the long chain, then the compound is going to end in cycloalkane. But if the number of carbons in the long chain is more, then the ending is going to be as an alkane, and then the cycle is going to be a substituent in that case. So the ending will not be in the cycle. So this is an example in here. You have 4 carbons in the cycle, you have 6 carbons in the chain. So the ending is hexane, and then the 4 carbons is going to be a substituent. It's going to be 1 cyclobutyl hexane in that case. Same thing over here. 7 carbons in the chain, 6 carbons in the cycle is going to be a cyclopentyl is going to be a substituent. Notice if it's a substituent, always the ending is YL. Always the ending is YL. Okay, substituents, YL. And then your chain. Properties of alkanes. Alkanes are nonpolar compounds. Alkanes, they do have weak van der Waals forces. They are not soluble in water. So alkanes are not soluble in water. They are soluble in organic solvents. We did talk about their properties in there. So any alkane chain does have van der Waals forces, which is an electronic cloud around the carbon chain. And if we want to compare the melting and boiling point of alkanes versus any other functional group, that melting and boiling point is going to be really high in this case. So increasing the strength of the intermolecular forces increases the melting and the boiling. I'm sorry, I meant it has to be lower in this case. So any type of functional group is going to have a higher boiling point than that of the alkane. And then if you increase the length of the chain of the R group, then the melting point and the boiling point is going to increase. The boiling point of isomers normally decreases with the branching. So if you have a branch of 1, 2 here, in this case 1, 2, 3, 4, and 5, a branch of 5 carbons, it's going to, all of those are going to be 5 carbons. So the more branches you have, the lower the boiling point. And with respect to the melting point normally increases with symmetry because the molecule is packed. So if you have an alkane that is branched, then its melting point is going to be high and its boiling point is going to be low. In that case, the melting and the boiling points, they are opposite of each other. Please remember that alkanes, they should be insoluble in water no matter how many carbons they are, and they are only soluble in organic solvents.